rational function, something with a denominator. If you graph it and it's got an asymptote, well, that means probably at that point, then the limit's not going to exist. But if you graph this thing, and a couple in the homework and a couple we're going to see today, and you see it doesn't have an asymptote, something is canceling out. You know what I'm saying? So you either have to algebraically manipulate it to see what cancels out, or just graph the goofy thing and just go really close to the right and to the left. If you did that here, at close to 0, this thing's going to approach negative 0.25. Okay? How do we feel about that, Chris? Yeah? Okay. We're going to practice more of these in Chapter 3. Did we talk about sine x over x on Friday? Great. If not, some people I got to, some people I didn't. Everyone on their calculator, graph sine x over x and make sure you're in radians. What the limit is as x approaches 0 of sine x over x. I want to know, first off, what is the function value at 0? Error. What is the sine of 0? What's the y length of the reference triangle of 0 degrees? 0. So this thing is equal to 0 over 0. F of 0 is equal to undefined. What's the limit equal to? 1. Look really close. Change your table values and look just to the left and just to the right. Is it going towards 1? Yes. It is. We're going to prove it later. This is something we're going to use a lot throughout the year in various ways and for different reasons. But something that you can hang your hat on is that the limit as x approaches 0 of sine x over x is equal to 1. Okay? For now, I'm going to tell you that, Eleanor. All right? And then you can use that whenever you feel like it. So if you get something like this, sine x, like in number 27, divided by 2x squared minus x, you can factor that denominator. You can factor that denominator to be x times 2x minus 1. And when you do that, you can split this up like this. You start here, 2x minus x squared, 2x squared minus x. This is the same as the limit as x approaches 0 of sine x over x times 2x minus 1. Any questions on that factoring out? Okay? Equals the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of 1 over 2x minus 1. Does that make sense what I just did? I took the product of the two limits. The limit of the products. When you take the limit of two things multiplied together, that's the same as taking the product of the two separate limits. So, because if I multiply these two things back together, you would get that. Now you can sub in what is the limit as x approaches 0 of sine x over x. That is 1. What's this equal to? Can you plug a 0 in, Jackie? Now you can. You plug it in here, 1 over 0 minus 1 is a negative 1. So the limit of this big, weird, hot mess is negative 1. And you can graph it and take a look at it to see that. Okay? Any questions on that one? All right, let's do a couple more. I want to do some of these piecewise functions. Does everyone know how to graph the greatest integer function in number 39? No. Okay, so write a note to yourself. Does anyone know where it's at? How do you graph the greatest integer function? Did you say yes, Jessica? You do know how?
The math button.
Math what?
Math, and then number.
Yes.
And it's number 5.
Yes. So graph it. It's a step function. Anyone who likes physics, you're going to use that a lot. But does anyone know what 39? What is the output for this greatest integer function? Does anyone know what it does? Where's it getting? What does it do? It inputs like absolute value returns the positive. What does the greatest integer do? It rounds down. Take a look at the values, right? Like what is, if you put in a 0.5, what value do you get?
0.
Yeah, you know what I'm saying? It rounds to the last greatest integer you've gone through. Okay? So, let's do some limit problems on it. So, here it's 0 all the way to 1. And then it equals 1. And it does that until you get to 2. And then it equals 2. Okay? So let me ask you this. What is the limit as x approaches 1 from the left? 0. What's the limit as x approaches 1 from the right?
1.
What does that mean in terms of the limit? Yeah, since the limit from the left does not equal the limit from the right, the limit does not exist at x equals 1. Does that make sense, Wayman? Let me ask you this. What is the function value at 1?
1.
Yes, the output's 1. Open circle down there, and then it's a closed circle up top. Okay, what is the limit as x approaches 0.5 from the left? 0. What's the limit as x approaches 0.5 from the right?
0.
What does that mean in terms of the limit at 0.5?
0.
The limit exists, and it is equal to that value of 0. Does that make sense? The limit as x approaches 0.5 is equal to 0. What's the function value at 0? I'm sorry, 0.5.
0.
0. Okay. Any questions on the step function? So it's a function where the limit exists everywhere except at the integers. Because at the integers, the limit from the left is not going to equal the limit from the right. Estella, how are we feeling with that? Okay. So let's take a look at the, and graph the x over absolute value of x function. That's a fun one. Take a look at it. X divided by the absolute value of x.